Calculus! This is AP Calculus Lesson 5-2! General and Power Antiderivatives.
Yeah.
Today's date is November 14th, 2018. We're here with our amazing class of Ben, Arrow, and Rochelle, and we are talking about paying the taxman. So when you take the antiderivative and you have things that are, we talked about yesterday, polynomials, when the polynomial, the group of the term is to the power of 1. Today we're talking about when that polynomial is to a power of 2 or 3 or anything other than 1. And when you do that, you need to pay the taxman. Yep, you're young. I know you don't need to pay taxes yet, but you're going to in AP Calculus. So when are we using this? I just said it. It's when you have a, I guess it's kind of, okay, I guess there's a miscommunication. It's when the derivative of the inner, so when your dinner is not equal to 1. For example, look at this guy. What is the dinner of this? I know the doubter. What is the dinner?
4.
4. Dinner is not 1, therefore you're using the taxman. So there are 3 easy steps for the taxman, and if you say taxman when you talk to people in college, they will look at you like you're crazy. The official method down here is called U-Substitution, which we will also be covering, and you get to choose whichever method you want. Last year, basically all 6 girls decided to do taxman unless I forced them to do U-Substitution, unless you're Joy, who kind of did both equally. So,
Why is it called
taxman, it's something that John created because he needed kids to understand how to do U-Substitution in an easier way, and this is what he came up with. And we'll talk about paying the taxman in a sec. I'll come up with my cutesy little, or his cutesy little metaphor, and you'll see what's going on here. So the first step, and it's very similar to the first step for U-Substitution, is to find things. We need to find U. There you are. I had to. I'm sorry. You have to find U. You need to find the taxman. Where is he? And you need to find du dx. Du dx. So you need to find 3 things for the very first step. So let's go find those things. What is U? U is going to be that inner, right? Have we talked about finding U before?
Yeah.
Roughly, kind of, in the past. What is U then?
Is it 4?
Is it 4x plus 1?
It's 4x plus 1. So it's everything inside. It's the inner. U, and we can say that off here to the side, U is equal to the inner. That's the same thing.
When you mean inner, it's like basically the number that's dividing with x or multiplying with x or with, like with this one, instead of putting u equals 4x plus 1, it's just 4x because it's dealing with the x.
Well, it's 4x plus 1. It's all of it. Yeah, sorry about the miscommunication. So it's 4x plus 1. It's everything on the inside. So there's a function on the outside, 8 times something to the power of 3. That's the outer, and then the inner is 4x plus 1. All right, who is the taxman? I'm just going to abbreviate with tax because I don't like writing taxman over and over again. Who is the taxman? The taxman is whoever is at your front door. Usually he comes through the back door, usually if like the front door is locked, but usually he comes through the front door, and there he is. There's the taxman, Mr. 8. He is our taxman. He's coming to collect taxes. We need to pay him to send him away. So our taxman here is 8.
Isn't it 8 times something equal to the power of 3?
That is the outer, yes. So the taxman is just part of the outer. It's like the A. You do A times powerhouse, it's the A. So the taxman is just that thing that's being multiplied. It's any number that's outside of the function. That's not a power. So that's your taxman. If you have 4/3 out front, then your taxman is 4/3. So far, so good? All right, and then we need to find du dx. Du dx. So we know what u is. When I find du dx, it's saying take the derivative of u. This is also called u prime. U prime is 4. And here's a cool little method. So because of this order, now I can pay the taxman. This is what you pay him with. You pay him by doing 8 divided by 4, which is equal to 2. I'm going to pay him with 2, so he's going to now turn into a 2. We have paid the taxman. We have changed the 8 into a 2. That's taxman. So I forgot to tell you what we're doing here, but we're now paying, or I guess it's a command, so pay the taxman.
So it's basically A over over u prime.
Yeah, a over u prime, if you're being very formal about this informal method, yes. So this integral now is going to be 2 times, in parentheses, 4x plus 1 to the power of 3 dx. That's what it looks like. And you don't need to rewrite this. I'm writing it out for the steps so you can see we have now paid the taxman by changing out the 8 for a 2. And then you just anti-differentiate. It's a big word. I'm going to do lowercase. Anti-differentiate. Take the antiderivative. Take the integral. When I do that, so this 3 is going to turn into so the power of 3 goes to a power of 4. So it's going to be 2 times 4x plus 1 to the power of 4. And then I need to
Divide by 2. So it's be 2 over 4.
2 over 4, yeah. Divide down by this power, so this is now going to be divided by 4. And then don't forget your c, yep. And that simplifies down to
1/2 times by 4x plus
1.
1. C.
4x plus 1 to the power of 4 plus c. There it is.
I see why they would choose this.
It's pretty straightforward. I know it's cutesy, but it's just to help you remember what's going on. It is a cute little shortcut. Okay, let's talk about U-substitution. By the way, it's the same problem. We should get the same answer. You use U-substitution. When do you think?
When daughter?
It's the same thing, because it's the same method. So when dinner is not equal to 1. So again, our dinner here is 4. It's definitely not 1. I'm looking at the inner, 4x plus 1. The derivative of 4x plus 1 is 4. It's not 1. So I'm going to be using U-substitution. You can be using U-substitution or Taxman unless I force you to do one way or the other. So instead of finding 3 things, because there's no Taxman, you only need to find those 2 things. So you need to find U. I'm not going to do it. And then you also need to find your du dx or your u prime. I'm just going to say u prime. Find u and u prime.
Not that.
I could say du dx. Should we be consistent about it? If you want it, you can be consistent. Du dx, it's just more to write. It's u prime.
You don't have to find 8.
Nope, not in this one. So, what is u?
4x plus 1.
That's the inner, yep, 4x plus 1. And I need to find du dx. And it is kind of important for this one to actually write out du dx. I realized now after telling you that you can write u prime. It is kind of important because that dx is going to be part of our equation. Du dx is equal to the derivative of the inner. It's 4, yeah. So dinner is 4. Okay, now that goes to step 2. Get d of x. And I guess if I was writing it all out, get d of x by itself, or solve for d of x. So if I'm solving for d of x, I have this equation right here. Du dx is equal to 4 over 1. Treat it just as a mixed fraction. So I'm going to cross multiply here. Cross multiply. And I'm eventually going to get this 4 dx is equal to 1 du, or just du. And then if I divide both sides by 4, I get dx. And that's what I'm trying to find. So dx, which we just did for step 2, is 1/4 du. So far, so good? All right, step 3. Now we're doing some substitution. And that's the whole point of U-substitution, because there's substitution. We're going to substitute u and dx. So u was 4x plus 1. Oh, look, there's a 4x plus 1 right there. So that means this integral now, and I'm going to I should have color-coded this. Let's go to green now. Now that I'm doing my U-substitution, I'm going to have my 8, which used to be my Taxman. On the inside, I had a 4x plus 1, but that 4x plus 1 is u. And that's u cubed. I haven't touched the cubed. And then I want to write dx here, but we know what dx is. Dx is just 1/4 d of u. So I'm going to do some substitution right here. We used to have a dx. This dx is now turned into 1/4 d of u. So far, so good? No? Yep, okay. So we've now substituted in for u, we have substituted d of x. Let's go ahead and anti-differentiate. Take the antiderivative. We'll switch to orange here. Anti-differentiate. Okay, I can take the antiderivative of 8u to the power of 3 because that's going to turn into 8u to the power of 4 divided by 4. And I still have this times 1/4 du. And that can be simplified a little bit. If I simplify this, that turns into what?
It would be. Can you cross multiply?
Oh, I don't need a du anymore, do I? Because I took the antiderivative. I'm sorry about that. When you take the antiderivative, the d whatever goes away. And this is just times 1/4. Sorry about that.
It would be 1/2, wouldn't it? Times u to the power of 4.
Yeah, so 1/2 times u to the power of 4. Because on the bottom we have 16. 8 divided by 16 reduces to 1/2. And finally we are on step 5. Step 5 is to plug u back in. Well, we know u is 4x plus 1, so everywhere that I see a u right here, which is just that one u, plug in 4x plus 1. So now this turns into 1/2 times 4x plus 1. Ooh, there's a teacher error up here and I already see it. I'll let you guys catch it. To the power of 4. Anyone see the teacher error?
You forgot times by 8. There's a plus c.
There it is. Log it, arrow. As soon as I take the antiderivative, I should have a c there, I should have c there, and I should have a c there for my final answer. And there it is, my final answer. And notice how that compares up here. It's the same exact answer, just in a different way. What are your initial thoughts in terms of which one you're going to use, which one is easier? Anything?
One of them has 3 steps and one of them has 5 steps.
That is definitely something to point out.
They're both the same.
They're really doing the same thing.
Like, they're both easy. It's just the fact that the U-Substitution is just one extra step. Or, yeah, 2 extra steps.
Yeah. Ben, anything you want to point out?
No.
Which one do you think you guys are going to use?
I don't know.
Okay, I guess we'll see for the homework. That's all I have for the notes. There's no backside. You know how to use U-Substitution. You know how to use the Taxman. You will start playing with them for the homework. And that concludes the notes.